Complex circuits. Now, any complex circuit is a combination of series and parallel circuits. So if we look at my example here, I have, as we follow through the battery, there is one loop up to this point through one resistor, and then there's a fork in the road. This fork in the road shows us that this is a small parallel section within the large circuit. So there's a small parallel section that is in series with the resistor. So what we're going to do first is, our first goal is to find equivalent resistance. When you do this, you need to work at the smallest part and work your way out. So the smallest part here is going to be this parallel section. So if we add 1 over 2 plus 1 over 2, well, 1/2 plus 1/2 is 1, and then you take the reciprocal of 1, you get a resistance of 1 ohm. Now that's the equivalent resistance of this parallel section, so I'll change it red. So this section has an equivalent resistance of 1 ohm. Now we have a series that is a 2 ohm resistor and a 1 ohm resistor. 2, 1. Because that's in series, we would simply add those up. This circuit has an equivalent resistance of 3 ohms. So what we're going to do now is, finding equivalent resistance is one large step in the process. Now we need to work backwards and do things like find the total current. Well, total current, I equals V over R. So total current is going to equal 6 volts over 3 ohms. 6 over 3 is 2. So the total current is 2 amps. Now we start utilizing our various rules. And we need to find, one thing that's often very helpful is to label the resistors. I like to label them with letters. Resistor A, resistor B, and resistor C. So now what we're going to begin doing is finding all the different things, meaning individual voltage and current, individual voltage and current, individual voltage and current. Well, being that resistor A is in series with resistors B and C here, so I'll just call it resistor BC, we would say the total current is equal to the current in both of them. So, capital I, current A is going to be 2 amps, and current BC is also going to be 2 amps. Now we know, so at this point, let's solve for voltage of A, because right now we know the resistance of A is 2 ohms, it's written here. The current through A is 2 amps. Let's find the voltage of A. V equals I times R. So the voltage of A is going to be I times R, so 2 times 2, that's 4 volts. So A, we've covered all the bases on A. Let's look over here at BC. Now, first thing we need to do is treat BC as one resistor of 1 ohm. So we have to treat it as BC is 1 ohm. So resistance BC, we're going to write 1. I'm not going to put the ohm symbol in. Let's find the current. Oh, we know the current for BC. So current BC. Oh, sorry, I typed an E in there. Current BC is equal to 2 amps. Oh, whoops. 2 amps. Well, the only thing we don't know then is the voltage of BC. So let's look at this. V equals I times R. So the voltage therefore must be 2 times 1, 2 volts. Now, let's do a check here. In a series, the series that is A and BC, the total voltage adds up to the total voltage, or the voltage of the individual ones adds up to the total voltage. So, therefore, 4 volts plus 2 volts equals the 6 volts. That works. Well, now we're going to talk about B and C alone. So let's write resistance B, current B, and voltage B. All right. Resistance B, well, that's easy. That's 2 ohms. Current B, voltage B. Well, let's use a rule. This is a parallel section. In a parallel, which of the two items is equal no matter what? Is it voltage being equal on both branches, or is it current being equal in both branches of parallel? Think for yourself for a second. It's voltage. If the voltage on BC is 2 volts, the voltage along each branch is 2 volts. So there's 2 volts up top, 2 volts along the bottom. We'll come to the bottom in just a second. Current B then. Well, I equals V over R, so 2 over 2 is a current of 1 amp. And that'll make a lot of sense in just a second when we make a comparison with C. So we're going to say resistance C, current C, voltage C. And you might be saying to yourself, well, Mr. Wolf, those are the same resistance. Well, true, but let's work through the exercise anyway. Resistance is 2 ohms, no big deal. Because it's a parallel, it has the same voltage as both branches, so it has a voltage of 2 volts, and therefore I equals V over R, so 2 divided by 2 is 1 amp. Now, I said that would make sense here. Let's look at it. Current is 1 amp. Current is 1 amp along the top. Current is 1 amp along the bottom. 1 amp this way, 1 amp that way, and the two branches are equal in size, so it makes sense that it would be an equal sharing of the current. Then we look at the fact that from here to here there's a current of 2, and it's split evenly, 1 this way, 1 that way. Current BC here was 2 amps. It makes sense when you look at it. So we accomplished all of our tasks at this point. The next video will have a more complex circuit to break down.